Corporate Finance Core, Topic 4, Stock Valuation, Learning Objective number 3. We're going to value stocks using the dividend discount model. In the first two topics, we talked about the dividend discount model and relative value analysis. You can see the limitations of both those models. In the dividend discount model, many stocks pay no dividend or very low dividends, and people are relying on the growth of profits and maybe future dividends increasing. And price multiples or relative value analysis doesn't tell you if the stock's actually a good buy, it just tells you if it's cheaper or more expensive than its competitors or comps. A more common method to value stocks, or a common method to value stocks, is to compute the present value of free cash flows and not dividends. So I'm going to take the present value of free cash flows to the firm. This is the most common way of doing this method. So I'm going to use those unlevered free cash flows, take the present value of all future unlevered free cash flows. I'm going to call that the enterprise value of the stock. The enterprise value is the present value of all cash flows, assuming there's no interest payments in there. And then, as a reminder, by the way, free cash flows of the firm are the after-tax EBIT. That's before interest and taxes. Then take out the taxes, subtract CapEx, add back depreciation because it's a non-cash expense, and subtract changes in net working capital because those are cash needs of the business that are not included in EBIT. I'm then going to value the stock. I'm going to take the enterprise value, which is the present value of unlevered cash flows, and then I'm going to subtract out what we're going to call something called net debt, which really means I'm going to subtract out debt and add back the cash. And I'm going to divide by total shares outstanding. So one way of thinking about this enterprise value, you can think about the enterprise value as the value of all the firm's assets. Since I'm not subtracting any interest or debt cash flows in my cash flows here, it's really just valuing the firm's ability of its assets to generate cash. And then I subtract out net debt, in other words, kind of most of the liabilities or a lot of the liabilities. And one way of thinking about that is you're then getting back to equity, right? If I take the value of the assets minus debt, you're getting back to equity value. So, and I divide by shares, and that gives me my equity value per share. So again, you can think about this enterprise value as the value of the assets. You can also think of it as the value of the unlevered firm without debt. You can also say, some people talk about the enterprise value as the takeover value. It's the cost to buy all the stock and pay off the liabilities, or pay off its debt. Let's talk about working capital in this valuation model. So where working capital is right here. We're going to subtract the change in net working capital. But also cash is often included in net working capital. So let's talk about this relationship between net working capital and this valuation. So net working capital, or I'll usually just say working capital, is defined by accountants as current assets minus current liabilities. And it's used to assess the firm's ability to meet short-term liabilities. It's meet its short-term obligations. However, in valuation, the following items are usually excluded from net working capital. And what it comes down to is you're basically going to generally exclude all interest-bearing assets and liabilities. So I want to exclude any cash equivalents that generate interest, and also exclude any interest-bearing current liabilities such as short-term debt, loans, and current portion of long-term debt. Now let's think about cash specifically. What if it's not an interest-bearing cash equivalent? How do I treat cash in net working capital? Well, it comes down to a simple understanding of what cash is being used for in the firm. If the cash is absolutely needed to run the business, right? You need cash balances to pay your bills and cash in the cash registers. I'm going to include cash in my net working capital. However, if cash is generally held for other reasons, maybe kind of in case of downturn, they'll use downturn in the economy, they'll use that cash as kind of a rainy day fund, or cash is just kind of sitting around in case you need it for a future date, that cash will then exclude cash from net working capital. Now, if cash is included in working capital, that means you absolutely need it to run the business. Then you're going to subtract debt, not net debt, from EV to get your valuation. So let me go back to the last slide and talk about what I just said there. If cash is needed to run your business, I'm going to exclude it here. So no cash here. And I'm going to exclude it here because I can't use the cash to kind of pay off the debt. However, if cash is excluded from working capital because you need it, is not need it for operations, then I'll subtract net debt. So back to this example. If cash is excluded here, that means I don't need cash for working capital, which means it is available to pay off the debt. So, and this is the most common way of treating it. And if you're in doubt in valuation, use non-cash working capital and then do use net debt here and not just debt. All right, so let's do a valuation of Walmart where I'm going to assume cash is not needed in general to run the business. And I'm going to calculate an enterprise value for Walmart and then calculate its stock price using the free cash flow method, or DCF. So I'm going to go to my spreadsheet. I've got the last year's financials, just ended in 2019. I got my EBIT after tax, depreciation, CapEx, and non-cash working capital. I'm going to write there non-cash working capital. I'm assuming cash is not needed. And I got my free cash flows to the firm of $14.6 billion. We'll assume that ended yesterday. So now I'm going to forecast 1 year from now, maybe just making a simple assumption that it grows at those growth rates. So my free cash flows 1 year from now are 15.14 billion. I'll take that 15 billion, grow it by 3.69% for another 5 years, and then in the 6th year, I'm going to grow it by 2.4%. So here's my estimate of Walmart's free cash flows to the firm. 15 billion up to 16 billion, 17.92 billion. Then I'll take the present value of all free cash flows to get my enterprise value. Take free cash flow, divide it by 1 plus my discount rate. I'm going to anchor that, hit F4, it puts dollar signs in front of C and 26. Raise that to the 1 power, and I'm going to copy down. So here's the present value of the first 6 free cash flows. Now I need to handle year 7 through infinity. So I'm going to take the year 6 free cash flow, multiply times 1 plus that perpetual growth rate. I didn't need to anchor that, but it didn't hurt. That'll give me the free cash flow in year 7. I'll then discount that back by taking R divided by R minus G, perpetual growth rate. That's the value of the free cash flow from year 7 to infinity, stated in year 6. So I'll discount that back for 6 years. And then I'll add up all those free cash flows, and this is going to be my enterprise value estimate for Walmart. $440 billion is the present value of all free cash flows from year 1 to infinity. They have net debt of $66 billion, 2.85 billion shares outstanding. So my final valuation is going to be my enterprise value minus net debt. That's going to be my equity value divided by number of shares. And I get 131 valuation per share. Current stock price was 109 at the time of this valuation. So it looks like Walmart actually is a decent buy. So that's my valuation. Let's do a little data table, do some sensitivity analysis. If terminal growth is 0 to 3% and discount rate is 5 to 10%. So I have it set up here. I'll have a link here to my valuation. I have my factors listed there. I'm going to select all these. Data, what if, data table. I'm going to put in my rows here are terminal growth rates. That's that 2.4. And my column here are discount rates. That's the 6%. There's my 131. Terminal growth is 2.4 and discount rate is 6. And you can see my valuations go from $36 when there's a high discount rate and no growth to $250 when terminal growth is 3% and the discount rate is only 5. So what these are maybe my assumed range kind of reasonable range of estimates of these two most important parameters, in my opinion. And there are my valuations. All right, so there's my DCF valuation using a free cash flow model, and I assumed a perpetual growth rate of free cash flows in my 6th year. Let me do a little hybrid model. So this is a hybrid model. It's DCF. However, for my terminal value, I'm going to talk about terminal value. When I say terminal value, is once you estimate it cash flows per year, and then you get to some point where you're going to say, okay, what's it worth 6 years from now, in this case, or 7 years from now? We'll call that value the terminal value. One way to do it is a perpetual growth rate. The other way to do it is do a hybrid. At this point, let's switch over and use relative value analysis or price multiple. So here's what I'm going to do. I'm going to take the present value of the first 6 cash flows. And then in year 7, I'm going to assume Walmart will have a value multiple of 17. That value multiple is the enterprise value per EBITDA multiple, which is an industry average, I'm going to assume. So I'll assume that Walmart gets an industry average EV, enterprise value over EBITDA multiple of 17. I'm going to estimate the EBITDA at that period in year 7 of 32 billion. So if I take 17 times my 33, that's going to give me the value of Walmart in year 6. Whoops, I'm sorry. Here's my year 6 EBITDA is 40 billion. I think it should be worth 17 times 40 billion in year 6. 17 times 40 is that 682. So I'm going to take in year 6, I'll take the present value of that year 6 valuation plus the present values of the cash flows from year 1 through 6 and add it up and get my valuation. So let's take a look at the spreadsheet. It's already done for you. So here's my EBITDA in the prior year. So that was the last year. I then take that value, I grow it at 3.69% for 5 years. So that'll be 5 years from now. And then one more growth rate is at 6 year. So this is my EBITDA in year 6. So if I take 17 times the EBITDA in year 6, that relative value analysis says that Walmart should be worth $682 billion 6 years from now. So my enterprise value using the DCF plus my EBITDA multiple is I'll sum up these 6 cash flows plus take the EBITDA multiple in year 6 and discount it 1 plus R to the year 6. I don't have to do it to the year 5 because there is no perpetuity that adjusts the year. And then I'll take my valuation. I'll take that EV of 562 billion, subtract out net debt divided by number of shares. And so using that method, I get $170 stock. And then I do a sensitivity analysis, looking at EBITDA multiples ranging from 10 to 20, discount rates from 5 to 10. And you can see I get ranges of stocks, valuations between $80 and $216. So this is another method of getting a valuation, which is really a hybrid between relative value analysis and DCF. So let's finish off this section by doing an example. It's not Walmart, so let's jump to the spreadsheet and take a look at this valuation. So we're going to estimate the value per share of the following stock by estimating free cash flows. Again, that's my EBIT after tax, add back depreciation, subtract CapEx, subtract changes in net working capital for years 1 through 5. We're then going to apply a perpetual growth rate in year 6 and add the value of the perpetuity to that. And so let's go ahead and do the valuation. And then we'll go ahead and do it with a enterprise value valuation also. So sales in year 1 are 1 million. That's an assumption. Okay, so this is like a combination of what we're learning in this section, valuation, with the pro forma analysis we did in the first couple topics. So my sales growth rate are going to grow at 20% a year for years 2 through 5. So I'll take that sales in year 1 times 1 plus my growth rate, anchor that, and that's years 1 through 5. You got sales really ramping up. Cost of goods sold, the assumption of cost of goods sold from years 1 through 5 are 25% of sales. So I'll anchor that times my sales. SG&A is assumed to be 10% of sales. Depreciation as a percentage of sales is 11%. And I'm going to anchor that times sales. So now I can get my EBIT. Sales minus cost of goods sold minus SG&A minus depreciation. Let's check our numbers, see if we look good. 540 to 1119. All right, so far so good. Taxes, we'll assume a tax rate of 21%. So I'll take my EBIT times my tax rate of 21%, anchor the tax rate. I can get my EBIT after tax by just subtracting EBIT and taxes. I'm going to add back my depreciation. Now CapEx, the assumption on CapEx, it's 12% of sales. So I'm going to take sales. Well, let's put a negative sign in front of that. We'll take sales times CapEx as a percentage of sales. So there's my CapEx per year. Whoops, didn't anchor something. Let's anchor that CapEx percent. Now minus change in net working capital. Now net working capital, what is my assumption here? Net working capital year 0 is 66. So I'm going to make a note down here of net working capital. So it was 66,667. And then in future years, net working capital as a percentage of sales is 8%. I'm going to assume that's non-cash. So here's my estimate of net working capital years 1, 2, 3, 4, 5. So I need to subtract the change in net working capital. Well, it went from 66 to 80, so I'll take the change, 80 minus 66. So there's my change in net working capital, subtracting that. And then I'll calculate my free cash flow to the firm. After-tax EBIT plus my depreciation, subtracting my changes in net working capital and net working cap and CapEx. So it looks like it's gone from 403 to 836. I now need to get a terminal value. So this is the year 1 through 5, year 1 through 5 free cash flows. So let's use a terminal growth rate of 3% for year 6 to infinity. So I'll take my year 5 free cash flow. I'll multiply times 1 plus that growth rate. That is my year 6 free cash flow, divided by my discount rate, 12%, minus my perpetual growth rate. That is the perpetuity from year 6 to infinity. So this is the value in year 5 of cash flows going from year 6 to infinity. So I'm not going to take the present value right here, because I will just add these numbers together. So I'm going to add that year 6 to infinity terminal growth rate, terminal cash flow value. And then I'll do the present value right here. So here's what I'm going to do. Instead of taking the present value of all these numbers individually, I'm going to go ahead and use my NPV function. So a net present value function. is a function which takes the present value of all cash flows, assuming the first one is in year 1. So I'm going to do NPV. I'm going to put in a discount rate, comma. I'll put in all the future cash flows, years 1 through 5. Again, remember this 9.5 billion, it is in year 5 terms because it's a year 6 cash flow over R minus G, which is the value in year 5. I'll close that. 7.5 billion. The total value of equity is the enterprise value minus net debt. So I'm going to just do minus debt plus cash, since I'll assume I use a non-cash working capital. And the the stock price per share is the 7.4 billion divided by shares outstanding. So I get a $74.07 stock valuation. All right. So that's my DCF valuation using a perpetual growth rate, and we just learned the NPV function. Now, be careful, the NPV function assumes the first cash flow is 1 year from now, and I just put my discount rate in. All right, well, let's do a couple more things here. Let's talk about sales growth and net reinvestment. So sales growth and net reinvestment. A common assumption is to grow CapEx with sales. This assumes that production facilities are scalable with sales. All right, so if Walmart wants to achieve a 20% sales growth, it will need 20% more stores, say net fixed assets. So that's kind of that's an assumption. You know, the store doesn't get better at getting customers in there or selling things quicker. It just increases the number of stores. However, if production facilities are lumpy, often a small business builds a second manufacturing facility as it's getting bigger, doubling capacity. While sales are growing 20%, maybe it doesn't need to grow for the next 4 years. So think about that. You've maxed out your first factory. You buy a second one, kind of doubling your capacity, while sales are growing 20% a year. So you can probably go 4 years without another factory needed. So you need to think about net reinvestment and CapEx, particularly relative to sales growth. Now, a common way of estimating CapEx and actually CapEx working capital together, is to also, and depreciation, is to calculate something called net reinvestment. So if we take CapEx, depreciation, and changes in net working capital as a percentage of after-tax EBIT. All right, so let's think about that again. CapEx, we net out CapEx, depreciation, and net working capital as a percent of after-tax EBIT. So what would that mean? Well, CapEx as a percentage of EBIT is how much of your EBIT you're needed to reinvest in the firm's fixed asset. Change in net working capital as a percentage of EBIT would tell you how much you have to reinvest for, say, inventory growth. And then you subtract depreciation. So that's kind of a non-cash expense. So we call this net reinvestment. It's what percentage of your EBIT is reinvested in the firm or needed as a cash flow investment. So assume a firm needs to reinvest 10% of their EBIT to keep the growth going, keep the cash flows flowing. In this case, I can take my after-tax EBIT and get to keep 90% of it. So my free cash flows to the firm will be my after-tax EBIT times 1 minus my net reinvestment rate. So some analysts like to forecast using this way because it really makes you focus on growth rates of sales and how much I need to reinvest. Another common way to do it is to just do one other iteration of this type of shortcut. If I have my prior year sales times 1 plus the growth rate of your sales, that's the year 1. That's the next year's sales level. Then I multiply that times EBIT as a percentage of sales. So just like I did cost of goods sold as a percentage of sales, I can do EBIT as a percentage of sales. So all of this gives me EBIT because it's the new sales times EBIT as a percentage of sales. take that after tax, and then take out the net reinvestment. So what would that do for us? Well, here's what it does for us. I'm going to go back to my evaluation. Notice I did all of this work to get these free cash flows, 400 billion to 836. Using cost of goods sold, SG&A, depreciation, the tax rate, net working capital, CapEx, and so on. So I had to do all that work. However, I could do the same analysis using just these assumptions. Next year's sales are 1 million. They grow at 20% a year. And instead of doing all of this work, I just jump from sales to this number here. I'll take sales times EBIT as a percentage of sales. So 54% of my sales wind up in EBIT. I then multiply that times 1 minus my tax rate, and that's going to be my after-tax EBIT, and I multiply that times 1 minus my net reinvestment rate. Now my net reinvestment rate, it turned out to be 5.4%. I just kind of got the equivalent of what I did up here. So here's what I did. I actually netted out depreciation, CapEx, and change in net working capital divided by EBIT, and it turned out to be 5.47%. So that allowed me to jump from sales to free cash flows, just making an assumption on EBIT as a percentage of sales, a tax rate, and how much of EBIT is reinvested in the firm. That captures working capital, CapEx, and depreciation. So that's a nice little shortcut to have. So in this topic, we valued stocks using DCF.